This lesson, we are going to learn how to find the impedance and the phase angle of parallel RC circuits. We're going to look at the parallel RC circuit, the formula to find the overall impedance, and then we have an example. This figure 1, shows the parallel RC circuit. As you can see, there is a resistor R and then a capacitor C. They connect in parallel. Both of them also connect to a source Vs in parallel. So this is the parallel RC circuit. The formula to find the overall impedance of this parallel circuit is this. Z equals to, and then this part. Okay, if you look at here, this is very similar to the formula for finding two resistors that connect in parallel, which is this. R total, R equivalent equals to R1 times R2 divided by R1 plus R2. For the numerator, it's almost the same. This part is same as here. Instead of R2, the second resistance, we have the capacitive reactance, which is the resistance of that capacitor, and the R just the first resistor. Let's look at the denominator, this part. If you remember, this is the resistance, or actually this is the impedance for resistor and the capacitor connecting series. It is this resistor and then capacitor connecting series. At this portion, the total impedance equals to that R squared plus XC squared. So we can say the denominator is the total impedance, but for resistor capacitor connecting series. Next, it is the phase angle. The phase angle is inverse tangent resistance divided by capacitive reactance. Now I think we are ready for solving the example problem. In the example problem, we need to find the impedance of this parallel circuit, also the phase angle for the circuit. We know the resistance is given 80 ohm, capacitive reactance is 100 ohm. We are ready. We are ready to find the impedance and the phase angle. So given resistance equals to 80 ohm and capacitive reactance SC equals to 100 ohm, we can find the impedance of this parallel circuit Z. That is resistance times capacitive reactance divided by, make sure this is the square root R squared plus XC squared. Plug in numbers. R, that is 80 ohm, and the XC is 100 ohm, divided by square root 80 omega squared plus 100 omega squared. Use calculator, I got 62.47 omega. Now let's find the phase angle, theta. Theta is inverse tangent, but this time is the resistance over capacitive reactance. Resistance is in the numerator, is on the top. That equals to inverse tangent 80 ohm divided by 100 ohm. Punch the number in calculator. I got 38.66 degree.